by a code. That means you want to enter an instructions. So for that particular instruction, a cell is a code cell. If you just want to give a heading that what you are going to start, or what you want to going to write an instruction for, then a text can be written by introducing a text cell. If you are displaying some graphical output, if you are plotting some graphs, some visualization, then it can be visible through a plot cells. So these three cells are there. Second important thing for the Jupyter Notebook is that it supports code sharing. So if you have written some code and like to share with some other people's, then it can allow you to share that code immediately after writing, as you share other documents in the Google. Like you share the Google notebooks, you share the Google Classroom, you share the Google Excel sheets, spreadsheets, document sheets. Exactly similar to that, you can share this collaborative notebook file. Second is you can export this file as a Python notebook file. You can export it as a .py file. You can export it as a PDF file and HTML file, which is very easy for handling. And that's why the Jupyter Notebook is popular. The screen you can see here is a Google collaborative environment. So in this particular environment, options, that is, this is an untitled, see, .ipynb. So this extension is particularly for Jupyter Notebook file. Okay, when you write a normal Python file, then it will have an extension .py. In file, you have a different options. That means you can export this file as .pynb, that is Python notebook file, or you can export it as a Python file, that is .py extension, and other option, that is PDF and HTML. So here you can see there are two plus symbols given here. One is plus code and plus text. When you click on this particular line, a code cell will be inserted in the current notebook file. When you click on the plus text file, then a text cell will be entered. The difference between these two cells is the code cell will consider whatever you write here is an instruction, and it will get executed by using the Python. Okay. When you consider plus text and you insert a text cell, it will not be get compiled as per the Python instructions. It will be considered as a normal text, and it will appear as a text into your file, right? So the today's topic is NumPy. It stands for the numerical Python. It is a Python library that can be used for the scientific and numerical applications. I tell you here, the Python has numerous libraries to perform very numerous tasks related to the machine learning and data science. So NumPy is one of the libraries which provides specifically numerical operations and numerical applications on data. It supports creating and manipulating multiple dimensional array objects. So as I told you, multiple dimensional array objects can be a simple one-dimensional array or n-dimensional matrices. So some features of NumPy as it is used to perform mathematical and logical operations. So linear algebra operations are supported by NumPy, and that's why it is a basic library to study linear algebra operations. It is a high level, it also supports high level mathematical operations such as Fourier transforms. Okay. In this particular skill course, we will be focusing the use of NumPy for linear algebra operations. For those who are using Python install on their particular machine, when you install the Python, some IDEs have NumPy integrated with them, and they do not require to install NumPy. But some IDEs requires to install NumPy explicitly. So in that case, if you have a Python and PIP installed, it is an environment wherein you can use it to install various libraries for the Python. Okay. If it has been installed, then you can install a Python by using a simple command, that is pip space install space NumPy. Okay. So all of you, please don't worry about it. If you don't want to use this command, or if you don't want to use this, I'll tell you a very simple use of this all libraries in Google Collaboratory, wherein the environment is set up with all present libraries available under the Python. Google Collaboratories have all this library made in available. It's a cloud environment wherein you can use all supported libraries of Python readily available. You don't have to explicitly install, right? You just have to use them. Okay. So all of you can see here. I'll just quickly demonstrate you about the Google Collaboratory. So what you require for Google Collaboratory, I hope everybody is going to see this Google Chrome screen. When I'm going to demonstrate you how to use it for Google Collaboratory. Okay. So Google Collaboratory, as I told you, it is available with Google. So what you need is, you just need a Google account. So everybody have a account which is being used, integrated with the Google Gmail. So you just need to log in into your account. So if you have logged in into your account, here we access this particular section to access different applications provided by Google. Okay. So there is an option of Google Collaboratory, but if you have not used this Google Collaboratory earlier, then this application shortcut is not available here. Okay. So in that case, what you have to do is, you have to just log in your email account, then just simply search for Google Collaboratory. You can type here Google Colab also. It is called as a Google Collaboratory, and in short, it is called as a Google Colab. So when you type it, it gives you a link to connect with Google Colab. You just need to click on it, right? So this is an environment, right? So it will ask you to start with your first new notebook. So you can click here to create a new notebook file. Okay. So this is a first environment wherein you can see a new Google Colab notebook is been created for you. Okay, it will take few seconds to open the notebook. So this is a new notebook file which is created. So you can see, I'll tell you few things which you have to access during this particular class. So these are the different options. File. So locate in drive, that means where exactly you like to save this particular notebook file. You can locate it, you can save it. Open in the playground mode. So there is a playground mode wherein you can type as an compiler type of a thing. Then you can create a new notebook file if you want to create. If you are writing some code over here and suddenly you think that there should be a new file to be created for another algorithm, so you can click here as a new notebook file. Okay. If there are some existing notebook file available with you, you can click here to open a notebook file. When you click here, it will ask you which particular file you would like to open here, right? Then rename a notebook file. So you can just click on here and you can rename here. So like here it is demo. Okay. So here it can be created as demo.ipl Python notebook file. Okay. Or you can click here to rename it. So you can delete it if you don't want to use it. You can create a copy of it as a save a copy in a drive. Two very important thing, those students use a GitHub for practicing and sharing their codes or the stuffs, then this particular can be directly linked to your, this particular file can be directly linked to your GitHub account. Okay. So you can save this copy to a GitHub guest directly or to your GitHub account. Then different versions are available over here. So these two versions are very important. You can download this particular file as a Python notebook file, or you can download it as a .py file, right? And you can even print it. So another is edit options are available. You can notebook file and table of contents. Then, as I told you in the insert, there is an insert code cell and a text cell. Whereas the shortcuts are also available over here. You can use this shortcut to insert code file and the text file. Okay. So you can see when I clicked on the text file, it shows my different formatting options of the text. Okay. So this is, if I say, okay. So this I have set it. Okay. If I want to hold it, I can do it and I can execute it. So you can see it will not be executed. It is just displayed as a text, simple text. Okay. So whereas the other code file, it will be get executed when you type some instructions in the Python file. If you don't want to use all these earlier files, there is a shortcut available over here on the right hand side. You can see here. You can move this shell position, that is upward and downward. You can link some files or the different sources to this particular cell to have track that from where you will be using it, what you would like to type in this. Okay, you can write comments onto this particular, that is, if some instructions you have written and you don't remember that for what purpose you have used these instructions, then you can type a comment over it. Okay, so this comment will be visible when you access this particular file, that what this instruction is all about. Okay, different setting options are available, that what is the font size you would like to see, the spacing between it. Okay, so these options you can set it. You don't need it, but in case if you like. Okay, and if you don't want this particular instruction, it is incorrect and don't require any more, then you can just click here as in delete. It will get deleted. Okay, so these are the different options which are available. And one thing I'd like to tell you, when you are using this particular file, where all this file will be get saved. One thing, you can locate this particular file, that where it will get saved. Otherwise, when you will be using it, you can go to my drive. Okay, so from here, if you click on drive, after clicking on the drive, you can see that one folder is automatically gets created. It is called as a Google folder. It is represented by an yellow color. You can observe here, it is Colab notebooks. This file will be get created. When you open this file, all this Google Colab files will be available over here. Okay? I hope now you all will be familiar with Google Collaboratory. Most of the students might be already using it, but the few students, those who are not aware about the Google Colab, how to use it, and where to save this particular file, now will be able to use Google. Okay. So let's start with the first topics of this today's lecture. So in this particular lecture, we have set the three tasks to be taught. One is NumPy, creating n-dimensional array using NumPy. Second one is functions to create arrays and combining arrays. Okay. So the first is for NumPy. As I told you, it is a library available under a Python. So this particular library, it contains number of different functions to manipulate data. So array is one of the functions available under the library NumPy. So you need to import a NumPy library completely, or you can import the functions from NumPy library, which you will use during this particular session. So the first task is to create n-dimensional array by using NumPy. So in this particular lecture, I'm going to import array first. Okay. So array is a function which is available using NumPy library. So your syntax of importing a particular functions available under library will be from NumPy, that is from library, import a function name. Okay, so the function name is array. So from NumPy, import array. This is one of the way. Second one, yes, you can import is can directly import NumPy, okay, as NV, right? So what is the difference between these two is, in many of the cases, you can observe that this is popularly used. That is, import NumPy as NV. NumPy is a library which contains all the manipulation functions which are required for data. Okay. So if you want a one particular specific function only, then in that case you can write that specific function. That is from NumPy import array. For today's lecture, we are only going to use arrays. So I have used only from NumPy import array. Otherwise, if you don't know exactly that which functions you will require, which data manipulation instructions we are going to access from NumPy, then in that case, you can entire NumPy library you can import into the current program file. The instruction for this is import NumPy as n, right? So when you want to execute an instruction in Python notebook, you can use a key that is Shift Enter. Okay, and in case of Google Collaboratory, you can observe here a small play button is available. You can click on this. Okay, if I click on this, it will get executed. Okay, you can see the execution is going on here, and this particular instruction is getting executed. Okay, so now it's got executed, and now it will have a number 1. Okay, number 1 is, that is the, this is first instructions we have executed from this file. Okay, so now I'm going to tell you how you will create a list in Python. So, and what is the difference between why particularly NumPy is required? Because the students who have some basic knowledge or might have used in their first years of engineering Python, or might be nowadays in the 12th, so some Python introduction is also there. So you might not have used NumPy, but you have used list, you might have used set. Okay, so in that case, how list is different from the NumPy. Okay, so that I'm going to demonstrate first, and then you will understand the importance of NumPy particularly. So you can observe here, I have created a variable a is equals to, and I assigned 3 values to this variable. So it is a list. So 1.0, 2.0, 3.0, they are the values which I have assigned to this particular variable a. So I'll execute this instruction. And then I asked print a. Okay. So when you print a, it will display a list which we have created. That is 1.0, 2.0, and 3.0. Right. Now, if I would like to perform some mathematical operations on this particular list, that is some addition, what operations you can perform on a data, addition is there, multiplication is there, subtraction is there, then deleting some values, adding some new values into it, right? So one of this operation that is for multiplication, I'm going to perform for this. I said here, this is not an array of numbers. Why? Because when I consider this particular list 1, 2, 3, and when I want to perform an operation, that is a multiplied by 2, what I expect here, each of this element will be multiplied by 2, and I expect in the result I shall get, that is 2.0, 4.0, and 6.0. Okay. But now, if you observe here, when I execute this instruction, a multiplied by 2, what is happening here? It just repeat the list. Okay. So earlier list elements were 1.0, 2.0, and 3.0. Now when I perform a multiplied by 2, the list gets repeated at the end. That is, list is appended at the end of existing list. And now I have 6 elements, which are 1.0, 2.0, 3.0 as earlier, and again the new list, that is a second list, twice it will be done, 1.0, 2.0, and 3.0. Okay. Similarly, if I do here a multiplied by 3. Okay. So I hope you understand understood that what operation it is performing on the list. So this is just a list. When you multiply a list, the list repeat itself. List is repeating itself. Okay. So this 1, 2, 3 elements are appended first and second time. Okay. So the list is repeated 3 times multiplied by 3. But this is we are not expecting as a numerical operation to be performed in an array. What we expect is when we multiply any array by using 3, then each individual element of an array gets multiplied by this scalar number 3. This is what we expect. Okay? And this is the difference between NumPy, using NumPy and the simple list. Okay? So to perform numerical operations and to have numbers to be used as in mathematical operations, you need to use NumPy. Here I have used this function array which I imported here, and now what I'm going to do is I'm going to convert this particular list into an array. Okay. So I have created a new variable which is called as an ARR. Okay, this is a new variable is equal to I have used a function array. Okay, and from where this function array is available? Array is available from this particular library as we imported it. Okay, if you do not import it, then here it will fetch an array. It will tell you the array is not available. So before using this function into a file, you will have to import this. Okay, so import from NumPy, import array. Array is a function. So for this function, what I'm passing a list which I have already created. This is just a list which contains 1.0, 2.0 and 3.0. What this particular function will do, it will convert this list into a numerical array. That each and every element of this will now be treated as a number. Okay? And this number, as I said, it is 1.0, 2.0, 3.0. Then it will be considered as a float number. Okay? It will be considered as a floating point number. Right? So I'll execute this instruction now. You see, this instruction is got executed, and now we will have variable ARR, which contains a numerical array with 3 values 1.0, 2.0, and 3.0. Now we are going to print this particular array. So after printing it, we will have array displayed over here. So you can observe one very important thing, how it is displayed and how it was displayed here. When we said just print A. Print A was displayed comma separated list. Okay, it is a comma separated list. But when we have displayed or printed this array, it displays entire array with number of elements it has. That is first element 1 point. Nothing is there after the point 0 is there, so 0 is not displayed on here. If you have 1.1, 1.2, that might not displayed. Okay. So 1.0, 2.3 point. So these are the floating point values. A very interesting thing is when we try to perform A multiplied by 2 over here, it has displayed the list twice. Okay. Now we will try to perform this operation on this particular array and will execute over here, and you can see here it has not displayed the list twice, but it has actually performed a mathematical operation which we expected earlier. Okay? That is, each individual array element got multiplied by 2, and hence in result we have 1 multiplied by 2 as 2, 2 multiplied by 2 as 4, and 3 multiplied by 2 as 6. If you try to perform some different operation multiplied by 4, then you can have here, that is, each individual array element is now multiplied by 4. Okay, so it is 4 and 12. Okay. So what we have learned till now is how list is different from an array. Okay, how you will create an array. This is one of the way you can create an array. There are multiple ways. This is one of the way we have seen. If you have and list already declared, then you can convert that list into an array by using a function array, and you will need to pass that list as an argument to the function array. So we have passed that list as a function, right? So I hope it is clear to you how we have created an array by using a list. Now, if you want to see what is the size of this array, then for that particular size, to get a size of an array, we have a function called as a shape. Okay, dot shape. So array is now an object. So each function, for a function, whenever they're accessing a function, when you're creating a variable by using some functions, you will consider it as an object created in a Python. Right? And hence, few of the functions you can directly call by using this object name and call. Right? So one thing you have to notice over here is, if I want to know what is the size of this particular array, I am using dot shape. Okay. So if you want to display size of this array, how you will going to write it? Array name. Here my array name is ARR. Okay. And yes, this is ARR dot shape and execute it. Okay. So you will have here 3 number of elements there in a particular array. Okay, so what is the shape of this array? There are total 3 elements. Now, what is the data type exactly for this particular array? So we have created an array of 1.0, 2.0 and 3.0. Okay, which itself indicates that it's a floating point. So I try to see what data type Python returns for this particular array. So for that we will use a function dtype. Okay, the instruction is dtype. Again, you will use for variable, if you want to know its data type, then you will have to type a variable name or object name dot dtype. Okay, so dtype is for a data type. Okay, it will display the data type that particular object or the variable currently holds. Okay, which kind of data that variable is assigned to. So we can have, it's a float 64-bit because it is a machine which executes a 64-bit instruction. So we have this float 64. So we have an array created in ARR which is of 3 floating point numbers, right? So now I'll give you one task to create an array of odd numbers. You can see here an array of odd numbers between 1 to 10. Okay, so you can try this and you can write in the comment window that whether you got how to create it. Okay, so you will have to create an array of odd numbers between 1 to 10. Those who have environment available, they can do it. Those who don't have an environment available, they can write in their copy. And when I demonstrate you on the next line that how it has been done, you can cross verify from your copy that whether you got it or not. Okay, you can cross verify whether the concept which we have learned has been understood by you or not. Okay, and for that only I have created this, that you can write by yourself, so that what you have learned, that how to create an array, has been understood by everyone. Okay, right. So I'll go to the next line and see. So as I told you, one of the way is to create here. Earlier here in above example, what we did it, we created a list. This way you can go, and all of you know this way. So I'll tell you in this way first that how you can create it. So I'll insert a new code file over here, and I'll create odd variable is an array of odd numbers. So I given a variable name as an odd is equals to. So one thing is, number one is you can create a list and you can convert into an array. Okay, so what I'm going to do is I'll create a list, simple list. I'm not going to use any array function, right? So I'll write over all the numbers, odd numbers between 1 to this. Okay. And after creating it, I'll execute this instruction. So you can see here, we have created a list. Now all of you will be able to differentiate between list and an array. This is not an array. This is what? This is just a simple list. Okay. Now we want to convert this into a list. So we can keep override into the same variable, that is odd is equals to, or you can use another variable name odd array. Okay. Odd array is equals to, how you will create it? You will use a function and in bracket, what you need to pass? You need to pass a list which you would like to convert into an array. Okay, I want this list of odd numbers to be my array. So I will pass here odd. Okay, and we will print both. Okay, we will first print the list and then we will print odd number array. So I'll first print here list odd. You can see a comma separated list is created. Okay. And then I will print here my array, that is odd array. Okay. So you can observe here it contains elements 1, 3, 5, 7. Okay. This is an array. So you can perform any operations on this array as we did earlier, any numerical operations on the array. This is one way. Second is, if you don't want to create a list, okay, this two instructions can be combined together. You don't want to use the list and you would like to perform directly create an array of odd numbers. So this is how we'll go here. Okay. So what I did here, I created AR as an array variable is equals to function array. It is a function, so first it has opening and closing round brackets. And inside this, I need to specify the list of elements that array should hold. Okay. So I have already specified that we want an array of odd numbers between 1. So I have listed over here all the elements which I want to be there in the array. Okay. So here you can create it. You can execute this instruction. Okay. And then you go and print it. It has the same output as we did. Okay. So I think you have now understood that the second way, number one, how we did it, how we created an array by using a list. We created first list and then we passed it as an input to this array. Second one, here we directly have written the list of elements which we want to assign to an array. Okay. So this is the second way how we can create an array of any random numbers that we want. Okay. So similarly, you can print the shape. It now currently with the 5 elements and the data type. Now here all the elements are integers, so it will display that is 61. Okay. So earlier the array was of float numbers and now is an array of integers. Right. So is there any doubt up till now? Okay, so I'll go ahead with this. So second task is from the list is now you will be able, now here we are able to understand that how an array is used from NumPy, how array function is used for NumPy. Now functions to create an array. Okay, so in this particular two examples, this example 1 and example 2, you understood here like we can create an array of some numbers which we wish to assign to an array. But sometimes some operations may require to create an array of specific numbers, particularly when you perform a data operations on images, data operations on different Fourier transforms. So we might want sometimes an array of ones, the array of all zeros. We sometimes want to test some functions, an array of random numbers to be get generated. Okay. So these functions are available under this NumPy library. Okay. So in NumPy libraries, we can have various functions to create a specific array. Okay. So now we are going to explore which are those functions and what kind of arrays we can other than this random number arrays, which arrays we can create by using the NumPy. So here we can see first is creating an empty array. Okay. So this creates an array empty, but here one thing I'd like to tell you all students that empty array doesn't mean that the array is empty. Empty array here indicates that it creates an array and it assigns some random numbers. Coordinator, there is a background noise. Some background noise is going on. So please look into it and kindly remove this background noise. Who is talking? Okay. So here we have to understand when we are using this specific function empty. Okay. So this empty function from NumPy is going to create an array of specific size. So if you want to create an array of size 10, if you want to create an array of size 20 or array of size 100, any size, okay, n-dimensional array you can create. And what Python does with this empty array, it will assign some random numbers to this particular array. After that, you can use this random numbers if you would like to carry this some operations on this particular random variables, or you can override and assign some different values to this empty array. Some mathematical operations requires to create an array of random numbers, okay, and to test your functions. When you study the further topics, you will understand what is the use of it. So first of all, we'll see how this empty function is used. Now you can observe here what I have performed. I have created in second array AR2 is equals to, I have called a function empty. Okay. And what I have passed in opening and closing curly brackets is 3 comma. So this is very important. Just look at over here, that is this line number 16. Okay. This code line number 16 here. So in this particular function array, what we did, we in this opening and closing square brackets, what we have passed, we have actually passed numbers or the values which we want to assign to array. Okay. But now, if you observe over here, AR2 is equals to empty. In opening and closing square bracket, what I have passed is 3 comma. What it indicates a size of an array. Okay. So what I'm going to tell a Python compiler, I'm going to tell to create an empty array and assign 3 random numbers. Okay. So the empty array AR2, which is going to be created, will be of size 3. Okay. So see here, observe here, when I display for this AR, that is AR dot shape. How the shape is being displayed? Shape is displayed that which indicates there are total 5 elements in an array and there are no columns for them. Okay. There are simple 5 elements. Comma indicates that if it is a multi-dimensional array, then it has n number of rows and n number of columns. Okay. So number of rows and number of columns are being displayed. So now we have a single one-dimensional array. So in case of one-dimensional array, the size will be displayed as total number of elements and comma after that it's a blank. That is that there are no further columns there in the array. Okay. So 5 comma, it indicates the 5. And now here what we are trying to tell you, AR2 is equal to empty. That is a function empty I have used to get an array 3. And when we execute this particular thing, I'm telling you to create an array of 3 with some random. So I'll execute this first instruction, import. So it has imported now. And now we are going to execute the second instruction. So when you print it, what do you expect here? Okay. We expect that array 2 should have total 3 random numbers, as we have indicated that in the instruction that I want an array 2 with 3 random numbers. So you can observe here, it has created any three random number, that is 4.0, 8.0, 12. Okay. One more important thing I'd like to tell all of you is the empty is a function which is provided by NumPy library. This function creates an array of random numbers of size which we specify over here, and each of this element is a float type. Okay. By default, it will be of always a float type, right? So when you print array data type, it will say it is a float, okay, right? And if you like to print a size, so if you like to print the size here, so you can say print. How you print size? You have to indicate the array for which you would like to display the size. So I want to display a size of array 2. So I write array 2 dot. Okay, what I want. So there are different functions available. This is a very important aspect of any IDE. Why IDE are used? Because IDE will tell you the syntaxes which are available or the functions which are available under any object. Okay? So it will always indicates you whether if anything is incorrect in typing or correction is required in the instructions by highlighting that instruction as an error, and then it can also guide you throughout these are the functions available which you would like to use. Okay, but to display the size, okay, which function we have used? We have used shape. Okay, this shape function will also be available under this. So this is the shape function. So you can just click on it, or you can type array to value shape. So I'll display it. So as I have specified over here, array of total size 3, then it has created an array for me of size 3. Okay. You can try another example. Let's say here equals to, I'll create a temporary array. The function is empty. Okay. So opening, closing down bracket is the function. And inside this function, what I have to pass? I have to pass the size. Okay. I want to create, let's say, an empty array and random number array, which is of size, say 10. Okay. Then what I have to specify 10 comma. This is how we will specify. And this instruction is executed. The empty array is created of random number string and it has been assigned to 10. Now we will display this contents of the 10. So I'll say print 10. Okay. So you can see here random numbers are created. I told you in earlier that is it will create a float type random number array. Okay. So I hope it is clear to you how to create and random number array in Python. And this is very useful because many times if you want to test some functions wherein you require to create an array of 100, array of 10, array of 20 of random numbers, then in that case you will use this function. So second one is to create an array of zeros. Okay? I will create an array of zeros, creating an array of zeros. So sometimes you will require that each and every elements to be assigned a same value, and that is 0. Okay. So for that we have a function that is import zeros. You have to note here it is zeros. S is being there. So from NumPy I have imported a function zeros, and then I'm going to use this function zeros. So here an array we are going to create wherein every element of array is being assigned a value 0. So in that case also you will have to specify only the size, not an element. Okay. So I have created array 3 is equals to a function named zeros, and inside this function I have specified the size of array which I want to create. So actually I wanted to create an array of size 3, and each of these array elements will be assigned a value 0. So execute this instruction, and will print array 3. So you can observe it. Okay. So it is 0, 0.0, 0, 0.0 and 0, 0.0. So this is an array which contains 3 elements. The size of array is 3.
Hello,
And
Thing
each
madam.
of this element.
Thing madam.
Yes.
There is one question from the student that array 2 is an empty array, then why output is 4, 8 and 12? I have
Okay. So now listen here, as I told you earlier, the very first line that when we are considering from NumPy input empty. Okay. So here there is a contradictory, that is we are saying to create an empty array and array is having some values. Okay. So this is a random numbers. These are the random numbers generated. Okay. When you execute it, like say here you can observe array 2 and you observe here 10. Okay. What Python does over here, Python will create an array wherein you have just specified a size of an array, but we have not specified what exactly elements that particular array should have. Okay. So here Python will create a random number and will assign this random numbers as an elements to this particular array. Okay. And hence we have the array displayed over there like this. And here in this particular case, we have created 3 elements. So here we have got this 3 elements to be created over. Okay. So what it will consider? It will consider a range wherein it will be get distributed the total number of elements. Okay. So the 3 we have specified, we want 3 elements over here. So we got this 4.8.8. We want here 10 elements. So we got here the 10 elements. Okay. So when we are going to use in the numerical operations, when we are studying numerical operations, I will demonstrate you how actually it works. Okay, how empty array works and why it is required to create an empty array, and how we are going to use this empty array in different operations of the data. Okay. So one thing you have to only notice here, that empty doesn't mean that it is opening using round brackets and empty. Empty here, it will assign some random numbers generated to each of the numbers. Okay. Whereas zeros will actually assign 0 as a value to the arrays. Okay. So here I have said that total 3 elements has to be there in array 3. That means size of array 3 is equal to 3, and those 3 numbers will be assigned a value of zeros, and it is called as an array of zeros. Okay. So when I print the shape of this, a data type of this, again it is 0, 0.0, obviously the shape will be what? Float. Okay. The shape is a float. Okay. So the next, what we can do is we can try to create an array of zeros of size 5. Okay. How you will create this? You want to create an array of zeros of size 5. You can try it, and then I'll execute the code. Okay. So what you can do is say m2 is equals to, your function for creating an array of zeros is zeros. Okay. In bracket, you need to specify what should be the size of this empty array. Okay. So this zero array of zeros, the size is I want to create an array of zeros which holds total how many elements? 5 elements. Okay. So this is created. When you display it, print, I will display it, print temp2. Okay. So you can have here a temp2 created with total 5 elements, and each of the element is assigned a value 0. Okay. So next function is creating an array of ones, where you can have an array to be created of specified size, and individual array element is assigned a value as 1. Okay. In array of zeros, what we have seen that we have created an array of specified size, and each element is assigned a value 0. Now by using array of ones, we can create an array wherein each array element will have a value equals to 1. So for this, you need to import a function called once, right? So from NumPy library, you need to import a function called once. So this once will be used similarly as zeros and empty. That means you need to use a function once, opening and closing down brackets. It holds the size of an array to be created. So I want to create an array 4 which have the size equals to 3 and each element is assigned a value equals to 1. So I have executed it. Now I'll print this particular array. You can observe here the array is created with total number of elements equals to 3. And each individual element is assigned a value that is 1.0, 1.0, 1. Okay. And when you display data type, it will be the float. Right? So you can try this by creating an array of say 10 elements and each individual array should have a value equals to 1. Okay, if I want to create an array of ones of total size equals to 10. So how you will create this then? Then I can have say a variable called p is equals to, you can try with this. What should be the function? I want to create an array of ones and total size is 10. So I'll need to write here temp is equals to ones, then in round bracket I need to specify size of an array is 10 count. Okay. So enter and execute. So that's created and then 3 with size equals to 10 and function once indicate that each element of 10 3 will have a value equal to 1. So I'll print it. Print 10 3. Okay. So you can observe here we have total 10 elements and each element is assigned a value equals to 1. Right? So up till now what we have seen how to create an array by using a list. If you have a list available, you can convert that list into an array. Second one is how you can create an array by using your own specific numbers. Then we have seen how to create an empty array which assigns a value to random numbers. Then next we have seen how to create an array of zeros, and after that we have seen how to create an array of ones. Okay. Now, if I like to combine the arrays, I have two different arrays and I need to combine them and to have a one single array. Okay. So combining of an array can be done by using two important operations called as a vertical stack and horizontal stack. Okay. Vertical stack operation and horizontal stack operation. So these two operations are very, very important in two perspectives. Number one is when you want to combine an array of two different numbers into a single array. So I'll create a single array of uh, from two different arrays. Okay, array 1 and array 2. Second one is by using vertical stacking and horizontal stacking, I can combine an array into a matrix. Okay, that means I may have an array of like first array is say for example roll number of the student, second array say for example marks of the student, third array say for example grade of the student. Okay, so in this particular case, if I want to create a matrix of instead of having three different individual array, I want a matrix which indicates that the column 1 is the roll numbers, column 2 is the marks, and column 3 is the grades. Okay, so I need to, in that case, I need to combine this three different array into a one matrix. Okay, so in that particular case, what we are going to use, we are going to use this vertical stack and horizontal stack operations. Okay, so one thing you have to note it down here. It has said that vertical stack. So stacking is putting this particular different array into as in vertical stacking or horizontal stacking. Okay, So the number one is the first we'll see how to combine array by using B stack. Okay. So what B stack indicates? It indicates a vertical stack. Okay. So the function for vertical stack is B stack. So again, you need to import this particular function from NumPy library. Okay. So what I am going to write here, from NumPy import B stack. Right. So as I told you, what is an operation we are going to perform? Combining arrays. So that means I need at least one or two array to be available so that I can combine it vertically or I can combine it horizontally. So for that particular operations, I will first create an array 5, which is of elements 1 to 3. So I created this array. Then I'll create I'll just display the elements so that you know that what is the available elements in the array 5. Then I created second array, array 6, which contains element 4, 5, 6. Okay. So execute this and display elements and the 6. So up till now what we did it, we created two arrays, array 5, which contains element 1 to 3, and array 6, which contains element 4, 5, 6. Now what I want is from these two arrays, array 5 and array 6, I want one single array to be created by what? Vertical stack. Right? So just observe here how I'm going to apply a function. See, array 7 I have created by combining array 6 and array 5. Okay. And how they are going to be combined? By combining vertical stack. See here, one very important thing you have to note it down, because many times student does this mistake of opening and closing round brackets. See, I am telling you each time, if from NumPy we are importing a function B stack. Okay, so it has its own opening and closing round brackets, right? And second opening and closing round brackets is used for what? It is used to indicate the list of arrays which you would like to combine. Okay. So which arrays I want to combine by using this stack is array 5 and array 6. They get combined and it will be assigned to what? Array number 7. So execute this. Okay. So I hope all of you have a pen and paper, so you can write it down in your copy that what you expect in array 7. Okay. If array 5 contains element 1 to 3 and array 6 contains element 4, 5, 6. Then what do you expect that array 7 should have? Vertical stacking. If I perform vertical stacking on array 5 and array 6. So one thing very for sure is that the array 7 will contain the element 1, 2, 3, 4, 5, 6. This is very sure because it is a combination of array 5 and array 6. But the difference between vertical stacking and horizontal stacking is how these elements are being assigned or listed in this resultant array cell. So you can observe here, we'll print it. See. Okay. So as I told you, this function is used to create a matrix of multiple arrays, right? So just note it down here and just listen for a few seconds at what I'm telling you. This stack is a vertical stacking. Okay, so what it did is it has placed and one array, that is array 5, at this particular place number 1. Okay. Then in the next place it has placed this array number 6 as it is. Right? How the arrays are combined? Arrays are combined like array 5. This is the first argument. Array 5 is being placed at first position. Okay. Then as a first, like stacking you do. All of you do the stacking, how you do? Okay. So this array 5 is being placed at the first position. In this resultant array 7, this is the resultant array. It starts here and it ends here. So it is the first element of this resultant array, array 5. Okay. Array 5 contains 1, 2, 3. And then next second array, that is second stack is being there. The second stack is the second array, that is 4, 5, 6. Okay. This way, how you got the result 1, 2, 3, 4, 5, 6. How they are combined, right? Now, if I print shape, okay, so just see what is the shape now? 3, 2. Earlier, if you observe here, when we displayed the shape, okay, like say, for example, for this particular alpha, okay, I'll just display one example. I'll take it here so that you can understand the difference between the shape of a single dimensional and multi-dimensional. So if I say print this, say array 6 dot shape. Okay, it says 3 comma because total there were 3 elements in the array. Okay, it was a single dimension, right? Now when we have displayed array 7 dot shape, it says that there are 2 columns, 2 stacks. This is stack 1, this is stack 2. Okay, so 2 rows are there, and how many? Each of this contains 3 elements. So there are 3 elements in each of this stack, each of this row. That is 1, 2, 3 in first stack, the first row, and in second stack, that is second row contains 4, 5, 6. And means we have the shape of this array 7 is 2, 3. Right? I hope this is understood to all of you. How arrays are combined by using V stack and how we can convert this array into numbers. Right? So now we are going to see how horizontal stacking will work. Okay, when you want to combine an array by using horizontal stack. Okay? So combining an array by using horizontal stack, how it will work? It will work that for VStack, we have used a function VStack from NumPy. Similarly, for horizontal stack, you have to use a function HStack. So how you will write? The syntax will always be same. From library name is NumPy. Import function which you want to use is a HStack. Okay? So from NumPy, import HStack. I have created, I have used the same arrays, that is array 5 and array 6, and specifically I have used this array 5 and array 6 again to create array 8 by using horizontal stacking so that you can understand the difference between horizontal and vertical stacking. See here, our array 5 has an element 1, 2, 3. Okay. Array 6 elements are 4, 5, and 6. After vertical stacking, I got the output in array 7. Now I am performing operation array 8 is equals to what? H stack, that means horizontal stack. Function open end using round bracket. Inside that I am going to provide the list of arrays which I want to combine by using horizontal stack. So I want array 5 and array 6 to be combined by using horizontal stack, and the result will be assigned to array 8. Okay. So go to the library and execute this function. And now you can see here, display the result. See what is being done in horizontal stacking. See, listen all of you. Okay, in vertical stacking, this is a stack 1 put on the first place, and then vertical stacking में एक के ऊपर एक, जैसे कि one after the another we are putting array 1 by 1. Array 1 we have put, array 2 we have put, array 3 and so on. Okay, but we observe this particular column, that is this column 1, it contains element 1, 4. This column contains element 2, 5. This column contains element 3, 6. In case of horizontal stacking, what is going to happen? It has considered array 5 to be put at the first place in array A. So we have element 1, 2, 3 to be placed horizontally, and then after that we have array 6 elements to be placed horizontally immediately following the array 5. Is 4, 5 and 6. Okay, this is a very important difference you need to understand from vertical stack and horizontal stack. In horizontal stack, horizontally we are going to place the array elements one after the another. Okay, so we have array 5 first, so all the elements of array 5 will come first, And then we have second argument is array 6, then all the elements of array 6 will come, right? And then you will have the total elements equals to 6. So here in this case, if you display the shape of this array A, what it will have? How many elements are there? Total 6 elements. So it will be 6 comma. So it will have the shape of an array is equals to 6 comma. Right? I hope you understood the difference between horizontal stacking and vertical stacking. Right? Now your task is, I'll give you 5 minutes to perform it. You have to create number 1 an array of say 5 odd numbers. You can create any numbers. Okay, you can take any 5 odd numbers of your choice. Right? Second is you can create an array of say even numbers. Okay. Then third, you apply H stack and create new array using array 1 and 2, okay, which we have